Chapter 9 Review Part 1. To begin the review, let's look at Example 2 on page 534. You'll have a couple problems on your test where you're going to have to use inverse variation. Okay, Example 2 states that the variables x and y vary inversely and y is equal to 8. X is equal to 3. We need to write an equation that relates x and y, and we also have to find y when x is equal to -4. So we're going to use the given values of x and y to find the constant of variation, which is k. Alright, so we're talking about inverse variation, so we're going to set up our equation as y is equal to k over x. Wherever we have y, we are going to write 8. K is what we need to find so that we can write our equation or our expression, and x is equal to 3. Alright, so to get rid of the denominator, we're going to multiply by the reciprocal. In this case, we're going to multiply each side by 3. The 3's cancel out on the right. 3 times 8 is 24. So our constant of variation, k, is equal to 24. Alright, so to write your inverse variation, you will plug it back into y is equal to k over x. So we're going to say y is equal to 24 over x. There is your inverse variation model. Okay, the second part in it, example 2 says when x is equal to -4. Now you would do this if, let's say, you had to graph. So wherever we have x, we're going to replace it with -4, so we get y is equal to 24 over -4 divide y is equal to -6. Alright, the next problem we are going to look at is problem 39 on page 538. Alright, now we're going to talk about joint variation. When we're working with joint variation, we have 3 variables, x, y, and z. The model that we are going to follow for joint variation when z varies jointly with x and y is going to be z is equal to k times x times y. Again, we've got to find k, our constant of variation. Our given values are going to be x is equal to 3, y equals -8, actually y is equal to +8, z equals 6. Alright, so fill in everything we know. Replace z with 6. K we need to find. X is 3, y is 8. 6 is equal to k times 24. We need to find the value of k, so we're going to divide out 24. Simplify 6 over 24, and we find that k is equal to 1/4. So to write the joint variation model, we would say z is equal to 1/4 x times y. Alright, the second part of the problem says find z when x is -4 and y is equal to 7. So all we're going to do is fill in what we know. Z is equal to 1/4 times -4 times 7. Multiply your terms and you get z equals -4. negative 2 over x plus 3 minus 1. Alright, so to graph this, we can make a xy table. Alright, and then we can go ahead and just choose values that are going to make it easy to graph. Find our vertical asymptote. We're going to look at our k value, which is negative 1. So a horizontal line dashed through negative 1. Alright, so we know when we graph rational expressions, we're going to be getting a graph that has hyperbolas. Hyperbolas have two branches, which are reflections of each other. So just to get us going, I'm going to go ahead and choose an x value of 4. So when I plug it into my equation up here, actually 4 is not an easy one. Alright, let's go and make it negative 4. Okay, so I'm going to choose x as negative 4. So what we would get is 2 over negative 4 plus 3. Negative 4 plus 3 is negative 1. So negative 2 over negative 1 is going to give you a positive 2. And a positive 2 minus 1 is 1. So when x is negative 4, y is 1. So I'm going to go ahead and plot this point 4, negative 4, up 1. Alright, so it looks like we're going to have one branch over here in this area. Remember, your graph or your branch will never cross that asymptote vertically and horizontally. Therefore, my other branch is going to have to be a reflection of it over here. Alright, so you need at least 2 points. If I'm looking at my graph right here, I can see I've chosen negative 4 as an x value. I'm not going to choose negative 3 because negative 3 is the asymptote, so let's go ahead and choose negative 5. Alright, so let's see what happens when x is negative 5. When x is negative 5, we're going to plug in negative 5 in our denominator. Negative 5 plus 3 is negative 2. So we would have negative 2 over negative 2, which is 1. Then we have to plug in our k value of negative 1. So 1 minus 1 is 0. So that means my other point is going to be at negative 5, comma 0. Alright, and then just go ahead and sketch your graph as neatly as you can, following those asymptotes without crossing. Alright, since my first branch is here, I know now that I can choose x values that are within this region so that I can sketch my second branch. Alright, so I'm going to first go ahead and attempt negative 1. Okay, when I plug in negative 1, I get negative 1 plus 3, which is 2. So I get negative 2 over 2, which is negative 1. Put in your k value of negative 1. Negative 1 plus negative 1 is negative 2. So when x is negative 1, y is negative 2. I'll go ahead and plot that point. The next value I'm going to attempt to work with is going to be negative 2. So I'm going to plug in negative 2 for x. Negative 2 plus 3 is 1. This concludes part 1 of your chapter review.